Good evening to one and all. In the previous video lecture series, we had discussed about unconventional or traditional conventional machining process, and also we had discussed about the different types of unconventional machining process. Some of them are we discussed about a chemical machining process, a laser beam machining process. Uh, Now we are going to discuss about electron beam machining process. This is the 2D diagram of electron beam machining process, and this is also the another diagram. The major parts of electron beam machining process are the workpiece, which is fitted in the table, and this is the workpiece which is fitted in the table. The table moves leftwards and rightwards direction, and this is the deflector coil. It is used to deflect the electron beam from the grid cup to that of the workpiece, and this is the focusing lens, electromagnetic focusing lens, and diaphragm, anode, and it consists of a tungsten filament and the grid cup, etc., and the DC power supply, which is also connected to grid cup and the diaphragm. These are all the major parts of the electron beam machining process. Next, we will going to discuss about the working principle behind the EBM, electron beam machining process. In EBM process, high velocity focused beam of electrons are used to remove the metal from the workpiece. These electrons are traveling at half the velocity of light, that is 1.6 into 10 power 8 meter per second. This process is best suited for micro cutting of metals. With the high velocity beam of electrons strike the workpiece, its kinetic energy is get converted into heat. This concentrated heat rises the temperature of workpiece material and vaporizes a small amount of it, resulting in removal of material from the workpiece. There are about different types of EBM, electron beam machining process. Some of them are machining inside the vacuum chamber and also machining outside the vacuum chamber. This image clearly depicts the various main parts of the electron beam machining process. And this is the first one is the electron gun. The electron gun consists of tungsten filament, grid cup, and also it acts as the anode. Next major important part is the diaphragm and the focusing lens, deflecting coil, and the work table through which the workpiece is fitted. Here the vacuum of about 10 to the power minus 5 to 10 power minus 6 mm of mercury is created inside the vacuum chamber. The electron gun is used to for the emission of electrons, and the next one is the tungsten filament. It acts as the negative terminal of the DC power supply, and the grid cup is used to direct the electrons to travel downwards from the upper portion. And the anode, it acts as the positive terminal of DC power supply. Next major portion is the focusing lens. It focuses the electrons at the point 0.01 to 0.02 diameter cross-sectional area. Next one is the electromagnetic deflector coil. This is the electromagnetic deflector coil. It deflects the electron beam to different spots according to the shape of the workpiece. Next, why the process had to be done in the vacuum chamber in the case of EBM. The entire process occurs in the vacuum chamber because a collision between an electron and an air molecule causes the electron to scatter and thus lose the energy and cutting ability. The first image shows the electron beam process in the vacuum chamber. The next image depicts the electron beam in the ambient air. These two images clearly shows that in the first image the electron beam directly falls on the workpiece material, whereas in the case of second image, which is not in the vacuum chamber, the electron beam scatters in and around. It leads to loss of energy and cutting ability. This is the major reason why the electron beam machining process has been done in the vacuum chamber. Next, when the high voltage DC source is given to the electron gun, tungsten filament wire gets heated of about 50 to 150 kilovolt, and the temperature rises to up to 2500 degrees Celsius. When the electron beam impacts on the workpiece surface, the kinetic energy of high velocity electron is immediately converted into heat energy. This high intensity heat metals and vaporizes the work material at the spot of beam. Power density is created about 6500 billion volt per meter square, and it results in the repeated pulses of about 1 to 16 Hz. Duration of about 4 to 6500 milliseconds. Next, we will going to discuss about the advantages. It is an excellent method for micro machining, and also it can cut drill holes or cut slots which otherwise cannot be made. It is possible to cut any known material. No cutting tool pressure or wear occurred in this process. It is distortion free machining, so precise dimensions can be achieved with the help of electron beam machining process. Next disadvantage is higher equipment cost, high skill is required. Only small cuts can be possible. Vacuum requirement limits the size of the workpiece. Application. It is used to produce very small size hole about 100 micrometers to 2 millimeter. And also it is used to produce holes in diesel injection nozzle. And also it is used in various different types of aerospace industries for producing turbine blades for supersonic engines and in nuclear reactors. This is some of the parts which is produced with the help of an electron beam machining process. Thank you.